All right, the back page of the test will be free response. Everything up to this point has been multiple choice, those first 20. This back page is free response, okay? Be worth about 10 points each on this back page, so 20 points total. And it gives us an exponential function, and we just want to know all kinds of information about it. So the first thing I do is I want to take a look at it. I want to see what it looks like. This is 2 times 5 raised to the x power, and then plus 1, okay? We zoom 6 this so we can get a look at it. There we go. And we want to know the information. First thing we know is x-intercept. Well, I'm saying, okay, when did it cross this x-axis? That's an x-intercept. And it never does. It comes out from way up here out of nowhere, and then it levels out. It never got to this line. So in this case, we would have none for our x-intercept. Our y-intercept, we can look and see that it's right here at 1, 2, 3. But do not write the answer 3. Everyone that's watching this video is going to have another leg up because they've seen this. The answer is not 3. A y-intercept is a point. Therefore, it has to be 0, 3. Okay? Our asymptote is just wherever our graph levels off. You can either look at the graph and find it, or you can see that it's right here on the end. But you do not write it as just a regular 1. An asymptote is a line. So therefore, it has to be y equals 1. Our domain is the same thing for all of these. All real numbers. It's going to go left forever and right forever. It might take it a while, but it's going to keep going that way for forever. Okay? Our range, we learned, has a lot to do with our asymptote. If you can find an asymptote, you can find range. Y and 1. But then we have to decide, is our entire graph greater than that asymptote or less than that asymptote? Well, like I said, this asymptote's right here at positive 1. So I look to see, where's my graph? My graph is all above that, okay? My asymptote's here at 1, imaginary line, and everything's up above it. It's going up above it. So my range is y is greater than 1, okay? Increase, decrease, you have to circle 1. As I read this from left to right, I see that it's increasing. And my interval is always the same. It's negative infinity to positive infinity. Don't get locked in too terribly much on that because that will change as soon as we get to our quadratics. Last piece of information on the left to fill in here is end behavior. As x approaches negative infinity, as x approaches positive infinity, we want to know where's y going. Okay? On the left side of my graph, it's leveling off at the asymptote of 1. On the right side of my graph, it's going up forever, so it's going to positive infinity. Okay? That's all the information that's asked on the left. The last thing is to sketch the graph. Well, I know some of these key points. I know that at 1, it's never going to touch that line. That's my asymptote. And I know at 2, 3 is where it crosses. And it looks about like this. There we go. Nice, simple sketch. You know a couple of the points. You know some of the important information. Go ahead, give me that sketch. Our second one, a little bit more complicated of an equation, but we do it the same way. So I look at it in the graph. I've got negative 2 times 4 raised to the x minus 8 power, and then plus 2. Okay? Zoom 6, take a look at this graph. Coming in, and then it dipped down really late there on the right side. Okay? So my x-intercept I can see is 1, 2, 3, 4, 5, 6, 7, 8. That's the point 8, 0. My y-intercept crossed at 2. Okay? At positive 2 is where it crosses. So I have 0, 2. My asymptote, it's got to be at this end number. So y equals 2 has to be my asymptote. My domain is all real numbers. My range is y something 2 My entire graph this time is below my asymptote, okay? So here was my asymptote and everything, it went down from there. So it's less than that asymptote. Increase or decrease, circle 1, this one decreased, and my interval is the same, negative infinity to positive infinity. Last thing, I want to know that end behavior. So as x approaches negative infinity and y approaches something, and as x approaches positive infinity, y approaches something. Well, my left half of the graph, as it goes further and further left, it's going to keep getting closer and closer to that asymptote of 2. Okay? On the right-hand side, as I go further right and right and right, oop, there it goes. It dipped way down. It's going to go down all the way to negative infinity. It's going to go down forever. Okay? Now, really quickly, I just kind of want to address something, and it's one of those, I made a couple extra clicks to the table at one point to check something. I thought it was a bit odd that our graph says that our intercept is 0, 2, and yet our asymptote is at 2. So what that says, if we were to sketch this graph, is that 1, 2. This is our intercept, but this is also our asymptote. That's because your calculator runs out of digits to estimate to. So it just estimated and said, okay, at this point, we're pretty much at 2. But we know we're not really at 2 because we can never get to 2. That's just your calculator kind of having a little bit of an error. Also, I extended that graph out a little bit because it's actually at 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 0 is my x-intercept. So there's my general sketch of the graph. It's not got to be perfect. It's just got to be pretty close. Okay? So just trust your gut on some of these. This was a bit of an oddity for my intercept and my asymptote to actually say they're the same on the same level. It's just because our calculator, they're so close that our calculator rounds it up a little bit for us. It's probably 1.999999999, whatever, however many nines right here. So our calculator says, okay, that's pretty much 0, 2.